All right, kiddos, quick review with multiple alleles, and we're going to use some blood type problems to help us get that point across. Normally, we have two alleles for a gene, dominant, recessive, or sometimes they'll both be dominant, maybe incomplete dominance, maybe it's codominance, but we usually only have two possibilities of alleles. Well, with blood types or multiple alleles, it's when you have three or more alleles for a certain gene. For example, blood type could have the allele for blood type A, you could have the allele for blood type B, or the allele for blood type O. Now notice, both the A and the B allele are capitals. These are going to be codominant. So if they're both together, you would have blood type AB. Blood type O is the recessive allele. So the only way blood type O would show is if you have both O or recessive alleles there to be blood type O. So a quick refresher, the genotype for blood type O, two recessive alleles. If you're blood type AB, you have one A and one B allele. They're codominant, so they both co-show blood type AB. If you're blood type A, you could be homozygous for A, both A alleles, or heterozygous for A, one A and then one O allele, because the A will show, the O is recessive. And for blood type B, you could have both B alleles, homozygous for blood type B, or heterozygous, one B allele and one O allele, because again, B is dominant to the recessive O allele. A quick problem to help us explain how that works. The mother has blood type O. Well, she would have to be two lowercase i's for her genotype. That's the only way we could have blood type O. The father is blood type AB. Well, that means he has to have one A allele and one B allele. And notice how I write those. If it's blood type A, or if it's an A allele, it's dominant. B allele, it's dominant. Capital letters for those. If I cross this, right there, I'll have one A and one O. I'll have one A and one O allele, and I'll have one B and one O allele, and one B and one O allele right there. So if I'm trying to figure out my possible phenotypes, these right here would give us blood type A, so 50% blood type A, and then 50% blood type B. Now notice, you look at the genotypes, I have one A allele, one O allele. A is dominant, so A shows up. Same with here. I have one B allele, one O allele. The B allele is dominant, so it shows up. One more example for you to set this one up. If the mother is heterozygous for blood type A, hetero means different. So if we set that up, we'd have one A allele, and then one O allele, the recessive right there. That's how we write the O allele. So she's heterozygous. She has one A and one O. The father is homozygous for blood type B. Well, if he's homozygous, homo means same, we would set his genotype up just like this. So heterozygous for type A, homozygous for type B. And if we cross those, this first possibility would have one A and one B allele. Over here, I would have one B and one O allele, an A and a B allele, and then lastly, a B allele with an O allele. Now, if I'm figuring out, those are my genotypes. If I'm figuring out my phenotypes, the possibilities, well, there's a 50% chance of having blood type AB, that phenotype, and then there's a 50% chance of getting a blood type B phenotype. So if you look at the genotype here of blood type B, there's one B allele and one O allele. B is dominant to O, and so B will show up there.